What is happening, guys? Welcome back to Red Beard's Garage, and on today's episode we're going to be taking this Harbor Freight 420cc Hemi engine and building it to a 9,000 RPM monster. For this build I'll be using a 308 cam from Go Power Sports. A stock length billet rod with automotive grade bearings will help us to get longevity from our engine. For our valve train we'll be going with 1.3 billet ratio roller rockers, 65-pound double valve springs, and chromoly push rods. To make sure we can clear the new rockers, we're using a billet valve cover. Multi-layer steel head gasket and head studs will ensure us of a long-lasting engine. Billet flywheel with starter ring gear for safety. We had our new billet piston Cerakoted to keep heat from absorbing into the piston. Billet crankcase cover for block rigidity. A 34mm true Mikuni for maximum flow. And we'll be bolting all this together with killer bolts. You can find all these parts and the tools used in today's videos located in the video's description. First I remove the airbox, carb, muffler, fan shroud, coil, and throttle assembly. Next, remove the governor arm, emission box, and spark plug. Remove the valve cover and intake studs. After removing the flywheel fan and starter cup, thread back on the flywheel nut. Place a pry bar behind the flywheel and pry outward as you hit the flywheel nut with a hammer to remove the flywheel. Now we can remove the charging coil. Grab the flywheel key with some side cutters and pry upwards to remove. Now we can remove the rocker assembly and the head. Remove the starter and crankcase cover. Remove the cam, balance shaft, cam followers, and oil sensor. Remove the rod cap and push the piston out and pull out the crank. Remove the remaining governor arm from the block and make sure to grab the washer. Tap the oil sensor with a 7/16 tap and the governor hole with a 3/8 tap. I removed the crankshaft seal because we'll be Cerakoting this block. Drill out the small hole between the followers to help oil drain back from the head into the block. I can now fully disassemble the head for Cerakoting and porting. This is the best valve spring compressor for small engines. Make sure to check out the links in the video's description where you can find all the tools and parts in this build. Compress the valve springs to remove the keepers. The head has sharp corners, so we'll be smoothing those out and upping the port size. And we also are going to get our ports and head Cerakoted to keep the heat from absorbing into the ports. We can now build out our head. First, install the seal on the intake and the shim on the exhaust spring seat. Use a valve spring compressor to install the new double valve springs. I use Maxima assembly lube on all my engine builds. It has high zinc, so it'll help parts break in and last longer. The reason we want to check our oil clearance when installing a new billet rod is if we didn't have enough clearance between our new rod bearing and the crankshaft journal, then we're going to get premature wear and we could end up locking up our engine. If the gap is too large, then we're going to get some rod knock, which is going to allow this rod to bounce around in the engine, causing the rod bearing to fail as well. So it's really important that we check this to make sure the gap is right to get oil where it needs to be in our engine. Place the rod in a set of soft jaws and remove the rod cap. Install the bearings by lining up the notches on the bearing and the rod. Carefully place your crankshaft onto the rod. Place a small piece of plastic gauge on the crankshaft. Install the rod cap and torque to 26 foot-pounds. We're going to start at 16 foot-pounds and work our way up 4 foot-pounds at a time until you reach the 26 foot-pounds, alternating from bolt to bolt. Now remove the rod cap and check your plastic gauge squish. We are shooting for 3 thousandths. If less than 2 thousandths, you'll need to get your crankshaft turned. If more than 4 thousandths, you'll need to replace your crankshaft. We are right at 3 thousandths, so we're good to proceed with the build after scraping off all the plastic gauge. The reason we want to check our ring gap when installing new rings into an engine is the simple fact that metal expands when it gets hot. So if our gap isn't enough, then that means once the rings expand, they're going to bump into each other, and that can cause the ring to fail, or we can end up scraping up our cylinder walls. If the gap is too large, then that's going to allow excess blow-by to leak past the piston rings in the compression cycle. Now, if you have too big of a gap, that's going to cause your engine to smoke, or we could blow gasoline by our rings into our oil, diluting our oil faster. So it's really important and it's really quick to check our ring gap. If the gap is not enough, then we can use a ring grinder tool located in the video's description to grind it a little wider. We will have an in-depth video on this process coming out soon, so make sure to hit the subscribe button and the notification bell to be updated on our new engine build videos. Since we are using an aftermarket piston, the rings need to be checked for gap. Place the rings into the cylinder and use the piston to push it into the block. Use the chart on screen or included with your piston rings to determine your gap. We will be using a 15 thousandths feeler gauge. Place the feeler gauge into the gap. If too tight, then you'll need to grind it with a piston ring grinder shown on screen. If it's too big, you'll need a larger set of rings. Our new rings are perfectly in spec, so now we can install them on our piston. Install the oil spacer onto the piston into the lower channel. Next, install an oil scraper on top and bottom of the oil spacer. Install the black faced ring next with any numbers or letters facing up in the center channel. Now we can install our chrome face ring in the top channel with any numbers or letters facing up as well. Install a wrist pin clip into one side of the piston and snap into the groove with a pick. Make sure to orientate your piston and rod correctly before installing. Slide the wrist pin into our piston and through our rod. We can now install the last wrist pin clip. Oil the cylinder and the ring compressor and install the piston while leaving the piston skirts exposed. Make sure the opening of the rings are spaced out 120 degrees apart. Tighten the ring compressor as much as possible. Use a rubber mallet to seat the compressor against the block to ensure that our rings don't kick out. Tap the piston into the cylinder with the wood handle. Slide the crankshaft into the block. Oil the bearings and install the rod cap, repeating the torque process used before. I went ahead and installed the head studs next. Oil the studs and use two nuts jammed together to tighten. Torque the studs to 26 foot-pounds. Now install the cam followers. Line up the dots on the cam and the crankshaft gear to time the engine correctly. These engines are known to have a lot of crankshaft in play. That's where the spacing between the side cover and the crankshaft allows the crankshaft to walk side to side. We're going to be using the shims that come with the billet flywheel to eliminate this down to 10 thousandths of an inch. I started out by using one thick and one thin shim. Install the solid dowels into the block and install the billet side cover. Torque a few bolts and check end plate. We're shooting for around 10 thousandths end plate. If too much, then you need to add more shims. If too little, you need to remove shims. The kit does come with two thicks and one thin, so so you have plenty of adjustability. I ended up using one thin shim to get the proper end plate on this particular engine. Torque the side cover bolts and install the oil drain plugs. We can now install our head gasket and torque our head to 26 foot-pounds. Slide in the push rods and seat them in the lifters. Install the rockers and slide the retaining pin in. Your engine will need to be at top dead center when we install the rockers. My cam calls for 3/1000 valve lash. Use a feeler gauge and tighten the adjuster to get the proper gap. Once set, tighten up the jam nut to lock everything in. Oil the valve train and install the valve cover. Now we can install the starter. Place some valve grinding compound onto the crankshaft and twist on the new flywheel on the crankshaft to mate the two surfaces. Make sure to clean off all the compound when finished. I use a homemade crankshaft stop to keep the crank from rotating. Once lapped, I install the crankshaft key and tap it into place. Install the flywheel and starter cup and torque to 85 foot-pounds. I am installing a MSD style coil. Links to the coils is in the video's description. I'm also installing a grounding strap that grounds the coil as close to the spark plug as possible to get an even hotter spark. Place a 40/1000 feeler gauge between the coil and the flywheel magnets. Push the coil towards the flywheel and tighten. Rotate the flywheel to remove the feeler gauges. Install the intake, carb, heat shields, and fan shroud. Guys, make sure to check out the links in the video's description for every tool and part used on this build. This thing should produce in the mid to high 20s and is going to be just a great buggy engine. So make sure to stay tuned to the channel where we slap it on gravy bones and go give it a rip and see what she'll do. Thank you so much for watching and supporting. We love you guys, and God bless.